In this video, I'm going to introduce the state management updates in Respo 0.4. In Respo 0.3, we have a function called mutate to update the component states. Now it's removed in Respo 0.4. I figured out a better way to manage the states, so I'm going to explain it in this video. So previously, states is stored in a separate tree called state reference state. The structure of the tree is corresponding to the DOM structure. You may think like it's contained of several 1 integers. Maybe I can write here. It's like 0 water and 1 watt, and inside it there is a data field which stores the component data, and it may have some more child component called 0 and 1 and whatever. So this is the old solution, which is corresponding to the DOM tree. So you can imagine as the app grow, there may be very deeply nested components, and so the states tree can be very complicated. Also, it's not stable. Every time the DOM structure changed, the states may be stored in another place, so which is not very good to state the persistency of the state. So now in latest Respo implementation, I put the states inside the store, which you can see from the demo here. When I define the store here, I use states as the top level and use an empty hash map here. Empty hash map here to say the states is empty now. So the component tree may look for states in this hash map, but it will get nil every time. So by default, we have to use a function called all to define a initial value, initial state. So this is the part. I have to introduce the states with a more specific demo called this page. So in this page is a tree. Actually, it's a component called counter. It's called counter because I can click this button to increment the data here every time I click. So each counter may contain two counters. It's recursive, so it contains two counters with different cursors. So cursor, you may already heard cursor in ClojureScript from on. The Respo bonding, the right bonding in ClojureScript. This I call it cursor too, but my implementation is more naive. You can see I use keyword here and bind this cursor to this component, and in the component itself, it's just this component. Meanwhile, you need to use similar function to similar ways to pick data from this same state tree. Yeah, not a big deal by now. So currently this state tree is looks like this. You have states which is global, and then you have left and right, and in each hash map there is also left and right. But meanwhile, you get a date field. Data field it contains the component state, which is actually a number here. Yeah, in more occasions it's hash maps. It's hash maps, but in this demo it's a counter, it's a value. So you can imagine it's a binary tree. This root is called states, and it has left and right. More if you are more crazy, you can have one more tree called middle, and this component tree just grow. You have and there will be a middle in some of the hash maps. So anyway, you can see it's a tree. It's a tree of hash maps defined by hash maps, and the actual component states are stored in fields like data. So this is a tree. You can get a tree, and mu and then I can see you can understand it very easily that the DOM itself is a tree. It's a DOM tree, or you can call it a component tree. So this time it's much simpler. It's much simpler. It's not nested anymore. Yeah, this is the tree now by now. Like it's like 3 nodes, but actually 2 branches with a data field. This is the tree. This is the tree we want. So then the problem is how do we map this tree to this tree, which is mapping a DOM tree to a state tree. So what I do here is use a function called with cursor. This function will bound this keyword to the component, and inside the component it will get a cursor which contains this keyword we specified, and meanwhile it's the states we pass it to it has to pick the right branch called left. You can see from the web page. Not too large. I printed the cursor here. It's left and left. It's left and right. It's just a factor containing the cursors we specified here. So this is the way we map this state tree to the component tree. Yeah, then. I want to say, in Respo we want global state tree, which is good for hot code replacing. You replace the code and the state remains. And meanwhile, the states are defined in each component itself. Then you can share the components without modifying the code. It's exactly like React, but the states are stored globally. So the magic part here is the cursor. You get a cursor, you can send a message to the store and to update the states in the right place. Meanwhile, the cursor is maintained by Respo framework, the library. So
it's 23:30.
So you don't have to manage it by yourself. You don't have to write it in business code. Yeah, that's my point. So in this way, I designed the state management system. I wanted to combine the benefits of global states and modularization. So you may ask, how do we update the states then? So to update states, you have to collect the state and the cursor, and in a new function called just pick a name. In a new function you call dispatch, you pass an operation called states and the data here with cursor and its new state. And inside updater, just use a function to update in the right place with the cursor. Yeah, it sounds simple. But took me very long time to figure it out, and as a result, the code looks quite tedious. Yeah, that's all I want to say. Just this state tree and the concept of the cursor. Thanks for watching. You can read more about my Respo component on respo.site. Thanks.